Okay, so again, we'll go conic by conic. I'll review the parabolas first. I'll let you work on the parabola questions, and then I'll review the ellipse ones, and then I'll let you work on the ellipse questions. So this is just a quick review of what the formulas would look like, what the graphs look like, this kind of stuff. So remember that there's two types of parabolas. There's a vertical parabola and a horizontal parabola. The vertical has the squared is the x, and the horizontal has the squared on the y. Remember that those are the terms that should be by themselves. So the 4p goes on the other side, and sometimes like questions in homework or questions on a quiz or whatever might get you on that part. Remember that if there's a number on the front of the squareds, you would want to move it to the other side, okay, by dividing both sides by that term. If there's a number inside, so these are if the if the vertex is at 0, 0. But if the vertex shifts, then it should be x minus h squared equals 4py minus k. So remember, if this would be if it's at 0, 0. This would be if it shifts to hk. That hk, or 0, 0, is your vertex. You would use 4p. If it's positive, it's going to point up. If it's negative, it's going to point down. And then the p, remember, is the distance from the vertex to the directrix and the vertex to the focus. So we would figure out what p is, and we would go up and down p to determine the focus and the directrix. Remember, the focus is a coordinate point. So if it starts at 0, 0, it's 0p, but if it starts at hk, it's h and then k plus p. And if it's y would equal negative p, or y would equal k minus p if you're shifting it. And that directrix is a line, so it has to be the y equals. If the 4p is negative, then it flips it upside down. So now it's pointing downwards. The p is still the distance between the vertex and the directrix and the vertex and the focus, except that you go down for the focus and you go up for the directrix. Same thing here. If my vertex is at 0, 0, then my directrix is at y equals negative p. Actually, that should be positive p. Oh, no. That's if you keep the sign with it. So you're going up p, and you're still going down p. But remember that you would take, that's if you keep the sign on the p. That would be, the directrix would be the k minus, or plus the p if it's negative, and then minus if it's negative, so it would go down. Then your horizontal shifts to turn right or left. So now we've got a directrix that's a vertical line, which means it's an x equals. We've got a focus that falls inside that scoop again, okay? And our parabola points right if the 4p is positive, left if the 4p is negative. If the vertex is at 0, 0, then it's this equation here, which is y squared equals 4px. And if the vertex is different than 0, 0, like hk, it's y minus k squared equals 4px minus h. So x always goes with the h, k always goes with the y. If the 4p is positive, again, it points to the right. If it's negative, it points to the left. Again, focus is a point, directrix is a line, and this time it's an x equals instead of a y equals, like the first ones that are vertical. So what's going to happen is you'll get an equation, and you'll have to pull information out of the equation. You'll have to figure out your vertex, your focus, your directrix. You'll have to graph your parabola. And then the reverse. Remember, we gave you things like the vertex and the focus, or the vertex and the directrix, and you had to take that information and plug it into your equation. You want to first figure out which direction it faces and then plug it in. Does stuff sound vaguely familiar? I know it's been 2 weeks, but it's still there a little bit. Not at all. That's very frightening. Okay. All right. So let's try this one together, and I'm going to let you set you off on the other ones on your own. So x minus 2 squared equals negative 16y plus 5. What can you tell me? First of all, we know it's a parabola, but if they were all mixed together, I would see that there's only one term squared, and that's what makes it a parabola. What can you tell me about this parabola? Because the x is squared, it's vertical. Because the 4p is negative, it's pointing down. Yes? What else can you tell me? What's the vertex? 2. Let me rewrite that so it fits. 2, negative 5. Good. So I can start there. Positive 2, 1, 2, 3, 4, 5. There's my vertex. I already know it points down, so I know what it looks like. But I also need to find the focus and the directrix. So what is 4p? Negative 16. So if negative 16 equals 4p, what does p equal? Negative 4, which tells me the negative is consistent. Well, that's what makes it go down, right? I'm going to count down 1, 2, 3, 4, plot a point. That's my focus. So that is at 2, negative 9. I went from negative 5 down 4 places. And then up 4, 1, 2, 3, 4. Did I not go all the way down? Hang on, I didn't put that on the right spot. One, 2, 3, 4, 5. There's my 1, 2, 3, 4. That's my focus. And then up 1, 2, 3, 4. And there's my directrix. Which, remember, is a line, so it's a y equals. Yep.
The focus is always the one like inside that.
Correct. It's like inside that scoop. And the directrix, like if you think about it, the parabola can never cross through the directrix. So if your arrows are pointing towards the line, something's wrong. It can never cross through it. Questions on any of that? So a reminder again, if you make a mistake, it's okay. You can correct it, and then at the end, I'm gonna collect it. So this will be your first easy classwork grade. It's horizontal because the y is squared.
It faces right.
Good. It faces right because that's a positive 4p, right? So I know this is going to point to the right. Okay, what's my vertex?
6, -1.
Good. 6, -1. Always what follows the x. Opposite of what follows the x, followed by opposite of what follows the y. So now I go 6, -1. 1, 2, 3, 4, 5, 6, -1. There's my vertex. And I know it's going to point to the right because I have a positive 4p. So I already know the shape of my curve. Then what? What's 4p? A half. Yuck. Then what? Divide by 4, which is the same thing as multiplying by a fourth, right? And I get p equals 1/8. So that means I'm only going to the right 1/8, a teeny tiny amount, and that's the focus. And I'm going to the left 1/8, and that's the directrix. So it's harder to count it, obviously, when it's a fraction. All we have to do is basically we're changing our x this time. So we're taking our 6, we're adding the 1/8 to get the focus. So the focus is 6 and 1/8 and -1. And we're subtracting 1/8 to get the directrix. So 6 minus 1/8 would be, it's a line. So it's an x equals, and it would be 5 and 7/8. Subtracting 1/8 from 6. So you can convert that to improper if you want. It'd be 48/8, and then I get 47/8, which becomes 5 and 7/8. So it doesn't matter how you write that. Either answer would have been fine. But obviously to graph it, you've got to make it into a mixed number. Questions on parabolas? So again, we've seen variations as in, like we took maybe this would have been 1/2 here, y plus 1 squared equals x minus 6. You could see something like that. So remember, if the number's on the squared term, we have to move it to the other side. So this can't stay here. The squared term can be in the parentheses with another number, but it can't have anything in the front. So if I wanted to get rid of that 1/2, I'd do what? Divide by 1/2 or? Multiply by 2. So it would cancel from here, and I'd end up with y plus 1 squared equals 2x minus 6. Still a positive 4p, right? 4p would now be 2 this time, so p would be 1/2. But remember that the squared has to be on the side by itself, so you always want to remember that. If there was a negative on the left, yep, divide or multiply by the negative number, it would move to the other side. Is that what you mean? Yeah. Mm-hmm. Okay, any questions on parabolas before we move into hyperbolas? Into ellipses? Just kidding. Hyperbolas tomorrow. Okay, just like parabolas. Oh, wait, just kidding. I forgot. We got to do the equation, right? So now we're working backwards. We've got information about a parabola, and we need to put it into standard form. So the first thing I want to do is figure out, what does this parabola look like? So if it's -1, 3, I'm going to move left 1 and up 3. And that's my vertex. And my directrix is y equals 6. So I go up to 1, 2, 3, 1, 2, 3, 4, 5, 6. And I draw my directrix. So what do I know about this parabola?
It faces down.
Good. And if it faces down, what's my equation going to look like?
X minus h squared equals 4p minus 5.
And what do I know about my 4p?
It's negative.
Good. This is going to be negative because my parabola faces down. With me so far? So I already know the x minus h part, right? Because this is my h and this is my k. So I can get x minus a -1 becomes +1. The 4p I still got to figure out, but the y minus k part I already know. Now how do I know p?
It's the same distance from the directrix to the vertex.
Good. Same, the distance from the directrix and the vertex. So if I just count 1, 2, 3, p is 3, and because it is facing downward, I plug it in as -3. So x plus 1 squared equals 4 times -3, y minus 3, x plus 1 squared equals -12, y minus 3. And there's the standard form of this parabola. So you want to plot your information to figure out which direction it faces. From there, you'll know which term is squared and whether or not to make 4p positive or negative. And then you just count the distance. Remember, the p is the distance either from the vertex to the directrix or the vertex to the focus. So if I had given you a focus here, you would have counted to the focus. If I had given you the focus and the directrix, you would have taken the distance and divided it by 2. Questions on that one? Okay, then came ellipses. So ellipses were our oval-shaped conics, okay? Just like parabolas, ellipses can either have a horizontal major axis or a vertical major axis. The one on the left is my horizontal. It's wider than it is tall. The one on the right is my vertical. It's taller than it is wide. What determines that, or what makes the decision to make it vertical or horizontal, is whichever fraction the larger number is under, right? It's not necessarily the order. The order is going to actually be for hyperbolas, which you'll see tomorrow. but we want to look for the bigger term. So A is the bigger term. If the A is under the X, then it's horizontal. If the A is under the Y, then it's vertical. Order of the ellipse doesn't matter. I could put Y first or X first, and it doesn't matter because it's a plus. If my center is at 0, 0, then I would get like an x squared plus a y squared. If my center's shifted, then it would be x minus h squared and then y minus k squared. It always has to equal 1. So sometimes our equations aren't equal to 1, and that's the first thing we have to do is divide them all by the number that's on the other side. And then in the note part, that's basically what I just said. The bigger number is under the x term. The major axis will be the x-axis. If the bigger is under the y, then it will be under the y-axis. Or parallel, meaning it would be shifted up or down or right or left. The other relationship we needed to know in this section is that c squared is equal to a squared minus b squared. Because you're given usually like 2 of those pieces of information. Remember that your a is the distance from the vertex to the vertice. The b is the distance from the vertex to the co-vertices. And the c is the distance from the I keep saying vertex. It's center. That word should be center. To the foci, which is the plural of focus. And remember, the A and the C fall on the major axis, the B falls on the minor axis. And then I think one other thing on this, and we're good to go, that 2A is the major axis, 2B is the minor axis. So that's used when you are trying to find the equation of them, right? If I give you information and then you're trying to find the equation, sometimes you're given the vertices and the major axis, or the minor axis, or the major axis and the foci, something like that. You'll be given like two of those 3 pieces of information. Some way to find A, B, C. You'll get given 2 of those 3, so you can find the third. All right, so this one says find the center, the vertices, the co-vertices, the foci, and then graph it. So tell me what you know about this equation just by looking at it.
It's horizontal. It's vertical.
Vertical, and why is that?
Because the bigger number's under the y.
Good. The A is 25, and that's under the y. So this makes A 5. The B squared is what?
4.
Which makes B 2. Good. What's my center? Good. -2, +1. What's opposite of the x, and then opposite of what follows the x, and then opposite of what follows the y. So I go -2, 1, and I plot my center. Because it's vertical, we're going up and down the A, right and left the B. So I go up 5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. So I took the X, left it alone, and I took so this is the vertices. I took the Y and moved it up and down 5. If you count it out, it went to -4 and to +6. If you just take the K coordinate, subtract the A, and add the A, you'll get the same coordinate points. So some people prefer to use the graph, some people prefer to use the actual coordinate points, totally up to you. The B goes right and left 2. Right 2, left 2. And those are my co-vertices. So now I'm adjusting the x coordinate. Left means -4, 1. Right 2 means 0, 1. And then I just connect to make my ellipse. So I got the center, I got the vertices, I got the co-vertices, I graphed it. What I'm missing is my foci. So remember the foci, I need the c. How do I find the c?
A squared minus B squared.
Good. C squared equals a squared minus b squared. So c squared equals 25 minus 4. C squared equals 21, and c would equal the square root of 21. Now, if I want to graph that, I would approximate it, right? So 21 is in between the square root of 16 and the square root of 25. I can approximate it at like 4.5. And that's on the major axis. So from my vertex, or from my center, I'm going to go up and down about 4.5. 1, 2, 3, 4.5. 1, 2, 3, 4.5. And those are my foci. But to write them out as coordinate points, I need to keep them exact. So I'm adjusting the y. So the x is going to stay the same. The y, I'm going to add and subtract the square root of 21. So you could separate those out. 1 minus root 21. 1 plus root 21. Or you can write it as plus or minus. So this quiz, you're going to kind of get your questions from WebAssign, but your answers are going to go on a piece of paper because you're going to have to graph, and you're going to have answers like that, which are super sloppy to type in. So you're just going to use, like, I'm going to give you an answer sheet. If you're at home, I'll post the answer sheet so you can print it or model your paper to look like it if you don't have a printer. And then you'll actually write those answers out like that. So that's why I'll take either answer. The only other thing I would say is make sure that if your, like, square root could be simplified, it's got to be simplified. Like if that answer was square root 20, I'd have to rewrite it as 2 root 5. I'd approximate it from my original square root 20. But when I write it on my answer sheet, I make sure it's 2 root 5. Questions on that one? Folks from home, still good? I could not imagine being awake right now at home. Yeah, thank you. All right. Last one is the reverse. So now we're given information and we're finding the equation of the ellipse. So this time I gave you the focus and the vertices. And you've got to find the equation. So I'm just going to draw like a quick sketch because you're not going to have to graph this for points, but you would obviously have to graph it to get the equation. So focus being -3, 2, and 3, 2 means 1, 2, 3, up 2, 1, 2, 3, up 2. Those are my foci. I don't know what that is. Just making sure everybody's still awake. What do you already know about this ellipse? It's horizontal, which means the A is going under the X. What else do you know or can find? What's halfway between the foci? The center. Good. So my center, 0, 2. And we know one more thing. What helps us? What's the distance from the center to the foci called? What letter is the distance between the center and the foci? C. So I already know 1, 2, 3. C is 3. One piece of information got me all that. So I already can start the tops of my equations. X minus 0 squared plus y minus 2 squared. That I already know. And that will get you partial credit, folks.
Why did you put it equal 1?
Because the standard form is always equal 1. Yep. For ellipses and you'll see 2 for hyperbola, same thing. Okay, now I go to the second piece of information. Vertex is negative 5, 2, and 5, 2. So now I'm going negative 5, 2, positive 5, 2, and those are my vertices. What does that help me find? Good. A is what? Good. So A is 5. Left or right, both directions, A was 5. So now I have 5 squared is the bottom of that one. Again, I already have the little piece of information I need. The last thing I need is B. And we said that C squared equals A squared minus B squared. So if C is 3 and A is 5, 9, 25, negative 16 equals negative B squared, which means B squared equals 16. I don't even need B. B would be 4, but I don't need it because in my equation is B squared, which would be 16.
If you're writing the equation, could you just put x squared instead of x minus
Yep.
0?
So the end result, the most simplified form is actually to get rid of that 0. I don't know that I would mark it wrong if you left the 0, especially because it's going to be like an open-ended question. But you don't need the 0. You have to square the 5, like you can't leave it as 5 squared, it needs to be 25. But the 0 could stay or go, I won't mark it wrong. All right, questions for me on anything we reviewed today? So remember, you're going to submit this now. Go ahead, submit it now to that assignment. So you can start the quarter off with a nice, beautiful 100 points. And this is what's going to get covered on your quiz on Friday. It will be pretty similar. You're going to get information about a parabola, and you're going to have to find the equation of the parabola. You're going to get an equation of the parabola, and you're going to have to graph and find information of the parabola. You're going to get information about an ellipse. You're going to have to find the equation of the ellipse, and then you're going to get the equation of the ellipse, and you're going to have to find the information about the ellipse like we just did, and graph the ellipse. So there will be graphing and everything.
So it's going to be like very similar to
Yep. Yeah. So we'll review, like I said, tomorrow we're going to move into hyperbolas. Tomorrow and Wednesday we'll focus on hyperbolas. Thursday we'll review again the parabolas and the ellipses. I'll post a quiz review. And then Friday will be a quiz on those. And then next week what we do is basically take an equation that's not in standard form. We force it into standard form using complete the square. And then we do all the same stuff we've already done. And that's what your test next Friday, next Friday will cover, is all the stuff from 4.3 and 4.4 is what the complete the square is. Everybody's good? Relatively painless, slow and steady start. Again, you want to get that submitted. That is your that's your classwork assignment. Did I put the due time it now? I think I did, right? Yep, sure did. Okay. All right, tell me what you need from me. We good? Do you feel comfortable now that if we reviewed it again on Thursday, you'd be okay? Yeah? Yeah? Yeah, good enough? Yes? I don't need to force you to do a homework assignment tonight? I feel like, yes? No? Yes? Good, okay. All right, and remember that before the break, we had another one of these. So those are 2 great example packets that you could use to review before Friday's quiz, and then again on Thursday, we'll post the quiz review.